Today we are going to discuss rise over condition in JK flip flop, normal JK flip flop, and what do you mean by rise around condition in JK flip flop, and how to overcome or how we can avoid that rise around condition in JK flip flop. What are the solutions or what are the different techniques to overcome rising I am going to discuss today. So, as you know, this is a JK flip flop, and in the JK flip flop, you have the values of J and K, and we are inputting a clock signal, and here there is this Q is fed as the input to this NAND gate, and this Q bar is given as the input to this NAND gate, and this is the circuit diagram of a JK flip flop. And this one we already discussed, and the truth table for this is like this. That means if the clock is zero, nothing will happen, and this is the previous output, and it will retain the previous whatever be the value of J and K. That means if the clock is zero, that means suppose that this is a level triggering clock. That means this clock will be active during this period. That means this is the time period of the clock. This is the time period of the clock. Okay, from this is the time period of the clock, and half of the time, that means this is t by 2, and this is another t by 2, and for t by 2 period of time, this will be in level 1, and for another t by 2, that will be in level 0, and whenever it is in level 1, this will be active. That is what I mean by level triggering. Now, if the clock is 0, and whatever be the value of J and K, if the clock value is 0, whatever be the value of J and K, it will retain the previous output. That means, suppose that the previous output is X, previous output is X, it will retain that value, and Q and bar will be X bar. That means, this is what if clock is 0, if clock is 0, it will return the previous input, previous output. That means that for the next cycle, this will be Q cycle. And now we are interested only in only when clock is 1. We are interested only when clock is 1. And suppose that clock is 1, and suppose that the value of J and K are 0 and 0. What will happen? J equal to 0 and K equal to 0. What will happen? Suppose that J and K are 0 and 0, and suppose that this is X. That means previous value of this is X. Suppose that this is 0, what will happen? 0, what will happen? That means J and K are zeros, and clock input is again 1. And suppose that this output is, this Q is 0, that means Q is equal to 0, then QR will definitely be 1. And if Q is 0, here the input will be 0. And if QR is 1, what will happen? This will be 1. So this is the stage here. Now see, this is 1, 0 and 1. This clock is 1. Here also clock is 1. Okay, 1, 0 and 1, when you are adding these three, get 0, and the complement of that will be 1, and here it is 1. And if you take the product, or if you are adding 1, 0 and 0, what will happen? Again that will be 0, and when it is complemented, you get 1. Okay, now this is 1, this is 1, and we know that this is already 0, then this is 0, and Q bar is 1, this is 1. What will happen? 1 into 0 is 0, and when you complement that, again that will be 1. And if you are having 1 and 1, 1 into 1 is 1, and 1 is 1, and if you take the complement of that is, then that will be 0. That means if q equal to 0, after uh, if j and k are zeros, that means if the j value and k value are 0 and 0, and if the clock input is 1, if qn minus 1 previous value is 0, then it will retain that. Now I am going to check whether it will retain if this is 1. Suppose that the previous value is 1 and here I am going to make it as 0. And when this is 1, what will happen? This will be 1. And when this q bar is 0, this will be 0. No change for the other inputs. Then what will happen? If this is 0, 1, 0 and 0, then if you are adding, this will be 0, and when you take the complement, that will be 1. Okay. And here it is 1, 0 and 1, again you are adding, the product is 0, and here when you are taking the negation, that means negation you get 1. This is definitely 1 and 1. And as you know, this is already 0, then here it is 0, and this is already 1, here it is 1. What will happen? 1 into 1 is 1, and if you take the negation, that will be 0. And 1 into 0 is 0, if you take the negative, that is 1. That means if q is equal to 1 and q bar is equal to 0, again after stabilizing this, that means there is a slight propagation delay. After that, it is stabilizing at 1. That means whatever be the value of x, that means if the previous value of qn is 0, it will retain that value. If the previous value of this is 1, again that will be retained. That means if the clock input is 1 and if the value of j and k are zeros, then that flip flop will retain the previous value. It will retain, or it is remembering the previous value. That means here these two conditions remember those values. That means it is whatever be the previous value of qn, that is retained. That means there is no change for the output if the clock input is 0, or if the clock input is 1 and the value of j and k are 0 and 0. Okay. Now we are going to check whether what will happen if j and k are 0 and 1. J and k are 0 and 1. Now j is 0 and I am going to set it as k as 1. And I am going to have this q as 0 and q bar as 1. What will happen? I am going to check what will happen. And all these values we do not know what are these values. Okay, now what will happen? We know these three values. Clock input is 1, the value of j and k are 0 and 1, and the previous value of q is 0. If q is 0, q bar will be 1. Now, if q is 0, what will happen? This will be 0. And if q bar is 1, what will happen? Here this will be 1. Then we are going to check what is the output of these two NAND gates. Here 1, 0 and 1. We are adding, it will get 0, and when it is complemented, this will be 1. And 1, 1 and 0. Again the product, or if you are adding 1, 1 and 0, what will happen? 0, and again the complement is 1. And the input, this q is available here as 0, and this q bar is available here as 1. Then if you take the product 1 and 1, 1 and 1 is 1, and if you take the complement, again it will be 0. That means here it is 0, and 1 into 0, 1 and 0 is 0. If you take the complement, that will be 1. That means there is no change. That means if q is equal to 0 and q bar is 1, there is no change. There is no change. That means if q is 0 and q bar is 1, it is retaining that value. It is retaining that value. Now I am going to check what will happen if this is 1 and this is 0. What will happen? If q is 1, here this will be 1, and this q bar is 0, q bar is 0, so it will be 0. Okay. Now I am going to check what will happen. 1 and 1 and 1 is 1, and if you take the negative or if you complement it, that will be 0. Here it is 1, 0 and 0. If you are adding 1 and if you take the complement, that will be 1. That will be 1. Okay. Now this 1, that means this is 1 and this is 0. The previous value of 0 is put here, that is the input here, and here this will be 1. Here 1 is available, here 1. What will happen? That means the previous values of q equal to 1 and q bar is equal to 0 is put to these two NAND gates. What will happen? 1 and 0 is 0, and if you take the complement, this will become 1. That means this will become 1. And here what will happen? Here what will happen? 1 and 0 is 0. If you take the complement, 1 and 0 is 0. If you take the complement, what will happen? That is, now this has changed to 1 and 0. 1 and 0 is 0. If you take the complement, what will happen? That is again 1. Okay, 1. And that 1 is put here, and this 1 is put as input to this. Okay. Now what will happen? Here this one changed to 1. 1. Now again 1, 1 and 0 is 0. Take the complement, that will be 1. And here what will happen? 1, 1, 1. If you take the adding 1 and the complement is 0. And now this 1 is put here and this one is put here. What will happen? 1 into 1 is 1. 1 into 1, 1 and 1 is 1. And if you take the negative, then this will be 0. And now this will become 0. Okay. And now this 0 is put to this. And what will happen? 0 dot 0 is 0 and the complement is 1. And this is 1. Okay. Now that 1 is put here. Now that is stabilized. That means if the previous value of q is 1, if the previous value of q is 1, that is reset to 0. That is reset to 0. That means whatever be the value of x, previous value, if j and k are 0 and 1, whatever be the previous value of x, that will be set. That will be reset. That means that is reset to 0. That is reset to 0. And like this, if it is 1, 0, what will happen? This qn will be set. Qn will be set. Qn will be set and qn bar will be reset. That means these are the important ones, and now we are focusing on 1, 1, 1. What will happen if 1, 1, 1? Here, the rise of error condition is happening when the clock is 1, j is equal to 1 and k is equal to 1. Okay, we are going to discuss the rise around condition. We are going to discuss the rise around condition, and that will happen when j is equal to 1, k is equal to 1 and clock is equal to 1. And suppose that the initial values of j, k and clock are, this is j equal to 1, clock is equal to 1, k is equal to 1. And suppose that the initial value of qn is 0 and the initial value of qn bar is 1. Okay. Now what will happen? Then suppose that the previous value of this is 0, then definitely this will be 0. and the previous value of this is available here. And when you take when you are adding this 1 and 1, that will be 0. 1 and 1, that will be 1, and here it is 0, and here see this is 1 and 0 is 0, and it will be 1, and this 0 is available here, and this 1 is available here. Then what will happen? 1 into 0 is 0. If you take the complement, that will be 1. Then here what will happen? 1 into 0 is 0. Now this 1 is available here. Okay. Then 1 into 1 is what? 1 into 1 is 1, and if you take the negation, then this will be 0. Okay. Then when this is 0, what will happen? Then this will be 0, and this will be 0, and when this is 1, this has changed to 1, and this has changed to 1. Now 1 and 0, what will happen? 1 and 0, 0, and if you take the negation, this will become 1. And 1 and 1, and if you take the negation, this is 0. Then 1 dot 0 is 1 and 0 is 0, and if you take the complement, this will become 1. And when this is 1, what will happen? This is available here. 1 dot 1 is 1, and if you take the negation, that will become 0. That means this QN, if the clock period during the same clock period, suppose that this is the clock, and this is the J value, and this is the K value, and during this time it is toggling like this. That means it is switching in between 0 and 1. That means 0 to 1 to 0 to 1 to 0 to 1 to something like that. Okay, like that. That means this is called race condition. That means it is switching in between 0 and 1. That means that is not stabilized. That means if you have such a JK flip-flop, then you have to control that toggling or control that race condition, and this is at the same time. That means suppose that your this positive edge is having a time period of t by 2, and if this, that means for a change to happen, this is a propagation delay. That means if something happened here, then if it has to reflect here, then it will take some time to stabilize. That is called propagation delay. That means for a signal to propagate from this, that means for stabilizing that signal changes, there is some propagation delays there. If that propagation delay is less than t by 2, then this race condition will happen. If that propagation delay is less than t by 2, and if you have to overcome this t by 2 should be less than the propagation delay. If t by 2 is greater than propagation delay, definitely this will happen. So one of the conditions to overcome racing is you have to set your propagation delay, or you have to set the time period of the clock pulse that should be less than the propagation delay. And now another condition to overcome racing is use edge trigger. That means these changes happen only when that means edge triggering means if it is a positive edge trigger flip-flop, then use during this transition. That means from this 0 to 1 there is a transition, and this edge is called positive edge of the clock pulse. During that clock pulse only a change can happen. That means it is not level triggered. That means during a flash, this will change. That means use for if it is negative edge triggering, then during the negative pulse, that means from this 0 to from this 1 to 0 there is a negative edge, and during this transition only this one will change. That means if you are using edge triggering, you can overcome this racing. And another one is master slave JK flip flop. And in now we are going to discuss master slave JK.